Database design can be thought of much like building a car. Much planning and design in order to deliver high performance and fulfill requirements it needs to meet. The database is the backbone of the information system that exists in organizations today. Databases are used to collect information and organize it so that it can be accessed, managed, and updated. The following presentation gives a sample overview of 4 database models: hierarchical, network, relational, and object relational. Hierarchical databases are a form of database management system that is constructed with a tree-like structure where records are linked via branches that relate one node to another. The structure is such that the parent can have many children, but each child can only have one parent, and information can be repeated through the parent-child relationships. The hierarchical database management system provides support for large amounts of data by providing a tree-like structure that contains the parent, child, grandparent, and sibling relationship. It provides easy navigation, deletion, and addition of new information to the database. Searching for information at the top of the hierarchy is very fast. This type of database works well with hierarchical type information such as organizational information or machine parts. Where this type of database has drawbacks is with respect to slow retrieval of information at the lower levels of the tree. Additionally, more in-depth relationships are not supported but can be logically created, such as many-to-many relationships. This system was more advantageous when their data was stored on tape drives. This type of DBMS has subsequently been deferred in favor of relational database management systems. However, hierarchical database representation returned in the 1990s through the development of extensible markup language, which have been used to represent hierarchical data from many different types of domain, including proprietary application layer communications protocol and hypertext markup language. IBM's information system was designed as a hierarchical database during the 1960s. The IMS beginnings can be traced back to IBM's involvement with NASA to help deliver the first explorers to space by providing an IT backbone for the Apollo program. IMS has a long and rich and successful history. IMS is used with mainframe system and is used to manufacturing, financing, banking, retailing, aerospace communications, government, insurance, high-tech, and healthcare. This includes 90% of the top worldwide companies. Currently, IBM provides the Information System version 13 transaction on hierarchical database management system. It continues to grow organically as existing customers continue to invest in the IMS implementation. Another implementation of the hierarchical database is the Microsoft Windows Registry. Created by the Conference on Data Systems Language, Codicil, with considerable input from Charles Bachman in 1969, the network database model is an extension of the hierarchical database, which allows many-to-many relationship and increased flexibility and simplicity. Therefore, where the hierarchical database enforces a single parent for each child with a network database model, each child can have multiple parent records. The network database can be considered as a generalized graph where cycles are permitted. The advantage of using a network database model includes the simplicity of the organization of the data. Additionally, accessing the database is more flexible while adherence to standards is simpler. Because of the more natural entity relationship, this type of database became popular after the inception of the hierarchical database. Also defined by Codicil is the definition of the schema, device media language, and the data manipulation language as well. The database should be used when the hierarchical data needs more flexibility in representing their relationships. Several implementations of the network database model were prevalent. However, the reference implementation of such would be the integrated data store. IDS was developed by the inventor of database, Charles Backman, at the General Electric for their customer, Weyerhaeuser. Weyerhaeuser is a developer of forest products and software lumber, which has been in existence since 1900. The software then became commercially available as IDS-2 in 1975. However, it was extremely difficult to configure and use, and was subsequently superseded by the continued expansion of the IMS client base and the inception of the relational database model. The relational database model is by far the most popular type of database implementation. It is based on the relational concept developed by Dr. Edgar Codd. Dr. Codd worked at IBM when the idea was conceived in 1971. The purpose of the relational database model is to allow the definition of relations or tables which contain rows, sometimes referred to as tuples, columns, sometimes referred to as attributes or fields. This type of model offers simplicity in design, and unlike the hierarchical and network design, which had intrinsic linkage of data, the tables or relational databases are autonomous. Another improvement over the hierarchical and network databases is the introduction of the structured query language to specify what is retrieved from the tables. Disadvantages include issues related to data redundancy and quality. Tables can be designed to eliminate redundancy, but the designer must have an accurate picture of how the data should be modeled. Especially the data is to be transformed from another format such as Excel spreadsheet. The business rules associated with a database design could potentially be incomplete, and updates can carry a heavy price after the database goes into production. The most popular databases are developed by IBM, Microsoft, and the most dominant player, Oracle, DB2 SQL Server, and Oracle Database. However, newcomers such as MySQL and PostgreSQL are also prevalent. With the introduction of the mobile devices, relational data can be stored using a much smaller memory footprint by the use of SQLite. The object relational model incorporates object-oriented technology into the relational database. In this model, the relational database takes on the form of relations that are more complex than the relational database, which provide objects, classes, and inheritance supported in the schemas and query language of the database. It was created during the research in the early 1990s to give object-oriented developers ability to leverage their knowledge to integrate and work with database that supports concepts they are familiar with. The software developers will create their own classes that are integrated into DBMS. Advantages of using the object-oriented databases include the ability to support complex data type inheritance and behavior as specified via methods. Developers may also take advantage of the unified modeling language to design and implement the architecture of the application and database using a common nomenclature. Disadvantages include the lack of vendors that implement a true object-oriented relational database and lack of case tools to generate design and the schema associated with the object relational database. The Oracle database supports direct integration with object-oriented language Java through APIs. Support for a pure relational database is limited. However, as more vendors opt to use a layer between the relational database and the object-oriented application code known as object relational mapping frameworks. One such framework by Microsoft is called the Entity Framework, also known as Link to SQL. It's quite sophisticated at generating object-oriented representation of the database via the software development languages it supports. Another popular tool which has support for both C# and Java programming languages is Hibernate and NHibernate. Choosing a model. For voluminous data that requires a rigid tree-like structure, consider using the hierarchical data model. IBM has continued to refine and improve the hierarchical database it uses internally for IMS. Customers continue to use the product because it has evolved over the years to support higher number of transactions at a faster rate. Large customers who needed this type of robustness before the relational database took flight have continued to rely on IMS for their operations and have little security in moving to a relational model. For voluminous data that requires a cyclical tree-like structure, consider using the network database model. The network database model, while solving some of the problems of the hierarchical database model, did not gain as much acceptance and is not currently as prevalent. In actuality, both the hierarchical and network model can be represented in a relational database. For ease of design the relational database model presents the most popular choice. Volumes of material is easily available for designing relational databases. Design tools such as Irwin data modeling software makes the design process less intimidating and more refined. Simplicity in designing the database is very paramount, and the relational model can support a wide array of requirements depending on the vendor selected to implement the databases. Additionally, along with the SQL and schema definition, support for stored procedures and triggers which implement behavior on the database model is supported. The relational database model can be designed to accomplish the same hierarchical and network model for storing data into the database. It is very popular with web-enabled applications such as PHP, ASP.NET, and MVC. Object relational databases represent the most natural model for object-oriented software development paradigm. Object-oriented development, which requires intense upfront design, can bring the application object entities in close proximity to the database object entities. Object relational mapping tools allow relational database to map classes to database schemas. With this type of model, the application can take advantage of the extensibility and maintainability features of object-oriented programming.